Okay, this one, right? Hello, everyone. Yeah, well, my name is Olena, and I'm pleased to be presented today. Great to see so many people interested in AI. Well, all right. So we're going to spend the next 20 minutes or something talking about large language models, the challenges they pose, and also we'll try to answer a very complex question. Well, how can we evaluate, well, the quality of large language models? But before we start, I'd like to ask you a few questions just to get a sense of who has the practical experience of working with the large language models, with the generative AI. And yeah, well, the first question is, well, who works with the Gen AI, or who has ever worked with this technology? Okay, quite a lot of people, great. Next question, well, who thinks large language models are easy to evaluate? Amazing. Okay, I think we have something to talk about today. Okay, yeah, let me start with a brief introduction. So, yeah, well, I'm an analytical linguist. Actually, I'm that linguist who looks at the output, right? So, well, thinking of the very first talk today. I'm also a tech lead manager at Grammarly, and yeah, well, I'm a linguist with an background both in academia and industry. Well, at some point I decided to well, make a switch and will started working in industry, in academia than in industry. Well, and ever since I joined Grammarly, I worked on various projects ranging from responsible AI, where I was evaluating the product from the ethical perspective. And then I also spent several years working on the project called Correctness, or grammatical error correction. And on this project, I was responsible for building data annotation and evaluation frameworks. And around a year ago, I started working on a project that relies on large language models. And so that's why I decided to, well, choose this topic and share my experience. Okay, LLMs have definitely changed the game, and they've done it for several reasons. Well, first of all, this technology is widely available. Well, anyone can take this technology and build a product on top of that. So there are numerous downstream applications. Well, you can do anything. This technology is great, so it's magic. Well, but you have to pay the tax. You have to measure the quality and understand how well the product performs. Yeah, well, when I was working on this presentation, I was thinking of how to best structure my talk, how to, well, build the narrative, and I think, so the topic itself is very ambitious, so, well, no one really knows how to evaluate large language models, so I decided to try to answer these questions. And so what I'd like to do in this presentation is I'd like to we'll talk about classical evaluation frameworks. So we'll spend some time talking about, well, classical pre-Gen AI solutions and how to evaluate them. Then we'll talk about the challenges that generative AI poses. And, well, at the end of the presentation, we'll try to answer this. We'll come up with a solution. Well, how can one actually evaluate the quality? And yeah, well, of course, at the end of at the very end of the presentation, we'll make some room for your questions. Great. Classical evaluation frameworks. Like I said, these pre-Gen AI-based solutions. Well, actually, what I mean by classical AI-based solution is something that we have, we know many answers for. Okay. Evaluation. Well, any evaluation will stand on three pillars. And these pillars are represented by various metrics. And ideally, you have to combine these metrics and look at various data points to see the big picture of actually just to get a sense of what's going on in your product. And these metrics can be broken down into roughly three categories: automated, manual, and user-based. And each of them well, is illustrated on this slide with a few examples. Well, in fact, there are a lot of metrics. But yes, yeah, so we can just take a look at some of them. Let's say, so precision recall, F-score is something that you can measure automatically, right? So there are also some domain-specific metrics, let's say rouge or blue. manual. So manual evaluations is something that your annotators will do, right? So human raters can perform. So it can be a TPFP analysis. Well, a TPFP stands for true positives and false positives, basically, whether the output is correct or incorrect. They can also look at the data from a qualitative perspective, perform qualitative analysis, side-by-side evaluations or preference tests. So a lot of options. And user-based metrics. Let's say the acceptance rate will demonstrate so how many suggestions your users actually accept. All right. Yeah, so these are the three pillars that can provide you with a sufficient number of data points, more or less reliable. And now imagine you have to evaluate this conventional or classical solution. Let's take an example of grammatical error correction. Well, you can see an example, well, a sentence will demonstrate in some corrections. Well, these errors have to do with verb tense, errors, the use of prepositions, punctuation. And yeah, so when you have to evaluate a grammatical error correction system, you'll probably have to collect, just pull a sample of data, similar to this data, right? And yeah, let's try to apply this framework. Well, again, automated, manual, and user-based metrics. You would probably want to compute the F-score, right? And just to compute it, you need an eval set. And so there are plenty of open source data sets that you can take and evaluate your system against. If for some reason this data doesn't work for you, you can build a new data set. Actually, so what it takes, you need to find a pool of annotators. Well, ideally, these should be linguists, right? So let's not forget about the expertise. So these should be linguists. You can take any style guide that will prescribe and describe grammatical norms of the language you're working with. I have a few examples here that, so let's say Chicago Manual of Style or Associated Press will help you, so will assist in writing evaluation guidelines for the English language. So once the evaluation guidelines, then you will annotate the eval set, and you can also just generate a subset of data and send it over for annotation. You will ask your annotators to evaluate the system, and they will do a TP FP analysis. So grammatical error correction is a relatively black and white task. I'm not trying to trivialize it. It's still hard and it has its own complexities, but it's relatively easy to define what's correct and what's incorrect. You can also ask annotators to have a look, look into the data and do a qualitative analysis of what's going on, right? And they will provide you with some, let's say, FP patterns that you can further fix. And yeah, then you can take a look at the behavior of your users. Let's say, just as an example, it can be the acceptance rate, and that will give you a sense of how users will actually interact with your system. So what kind of things they decline, ignore, accept, etc. So yeah. Like I said, my goal was not to trivialize grammatical error correction, because I spent many years working on this task, and it's not that simple as it might seem at first sight. This framework more or less works. And then comes Gen AI, and it brings challenges. And like I mentioned, I'm a linguist. And I cannot avoid the topic of human in the loop component. Large language models do a great job, so they produce fascinating outputs, but without the linguist, it's impossible to understand the quality and basically navigate this technology. So it's essential that experts look at the output. That's why, so let's talk about the challenges, the two facets of challenges. First of all, large language models produce non-deterministic output, which is great, and that's intentional because large language models are meant to emulate human communicative behavior, and so like we do not use one and the same words 25,000 times a day, right? So there's some variety in our language. So the same is true of large language models. But basically, so this output is very hard to tame because so the scope of problems that we started working with is very broad. And it's hard to define it. So you see the output, so what's actually going on in the output? So what's actually being corrected? So what's actually being improved? So that's very complicated. So there are, of course, ways to, tame these sort of problems. You can control parameters, you can play around with the temperature, etc. But so that's so it has its implications. It can remove this human-likeness, which is undesired. Then, when you start working with, when it comes to working with annotators, with humans, so you face another scope of problems. So these tasks are very. Just because the output is non-deterministic, it increases the subjectivity of judgment. It's hard to write the guidelines that annotators can follow when they annotate the data. And I provide you with an example of GEC. So the concepts of TP and FP are relatively easy to define, but when it comes to these kinds of problems, so there's no black and white, there's no correct and incorrect. And actually, when we write annotation guidelines, we have to move away from these concepts of correct, incorrect, and talk about things at a high level of abstraction. And we have to describe phenomena at a more product and concept level. And like what used to be correct and incorrect is now rather useful, valuable, relevant, impressive, it's whatever. Going back to this framework, so why doesn't it work? Automated metrics. The phenomena we are working with are very complex, multifaceted, and there's no single metric, there's no cure all that can answer all the questions. So metrics do not exist for novel tasks. There are no evaluation data sets for novel tasks. So if you need to collect evaluation data, you basically need to collect it. You need to write guidelines and we'll kick off the annotation process. Manual evaluation. Yeah, like I said, it's hard to define things as correct and incorrect, so we have to start refraining from these concepts. Yeah, well, of course, we still do some classification tasks, like is it good, is it bad, is it great, is it not great, correct, incorrect, but the likelihood of getting random answers is pretty high. Well, subjectivity leads to inconsistent judgment. Again, this likelihood of just getting random things. And it actually leads to the problem. The problem that we face here is that you need to collect a lot of data just to get statistically significant results. And annotating a lot of data means actually a lot of time and cost a lot of resources. The annotation pace itself is very slow just because we work with complex and big things. User-based metrics. Going back to this acceptance rate, so what users accept is not always correct. So you have to look into the nature of things and understand why users actually doing that. So whether they really like it or not. So whether or they just accepted that because they trust your product. and it's hard to understand the causation. So the metrics have changed. So what's the reason? Is it because of the quality boost, or just, I mean, today user decide to accept everything? And yeah, well, just to substantiate my statements, well, let's have a look at this model output. So well, at top you can see the original sentence, well, and the sentence below well is a rewrite, and the large language so an LLM actually try to improve the sentence. So the original goes as, according to what was learned throughout the novel, readers learn that there are flaws of such attitude, pardon my reading, of such an attitude as seen through the protagonist's lives. And the corrected version goes as the novel unfolds, readers come to understand the flaws of such an attitude through the experience of the protagonists. Okay, imagine annotators have to label this data. So what are the questions that they have to answer? Is it correct or is it incorrect? Is it a matter of correctness? Is it a matter of impressiveness? So like, it's very hard to even formulate the hypothesis that you'd like to validate or invalidate. Okay. Let's move on to the last part of this presentation, and let's finally try to answer this question. So, well, how do we even build, can we build an evaluation framework to evaluate the quality of a large language model? Okay, so the 3 pillars have now turned into 3 question marks. So, but anyway, let's do our best, and let's try to look into each of these dimensions, and I'll try to share my experience and tell you what has worked for me and my team. Great. Automated evaluation. So when you look at this output, you can see, well, a lot of corrections, so the text is massively rewritten, so it's hard to understand what's going on. And like I said, there's no single metric that will just say, oh yeah, the model is performing better. Like, you need to come up with a set of criteria. So a set of criteria, evaluation criteria, is easier to develop when you break down a complex task into smaller one, when you basically decompose the task, and when you will evaluate these small facets of the phenomena that you're working with. And well, in other words, let's say a rewrite. So like, how can a rewrite be represented? So what are these like abstract things that will form the notion of a rewrite? A rewrite can be grammatical, and grammaticality is already something that we can evaluate, right? Is it correct or is it incorrect? So it can be tamed. Well, is the rewrite context relevant? Or let's say, is the style of the rewrite is relevant? So is it imitating the voice of the writer based on the whole context that the surrounding context that we can see? Well, is the rewrite impressive? So or things like that. Then we can also develop task-specific heuristics and measure the quality of things that matter to us. And yeah, I have an example of hallucinations. Those of you who have worked with large language models probably know that they hallucinate. Well, anyway, if you've used ChatGPT, so I hope you understand that you should not rely on and trust. Just take everything and trust. So large language models hallucinate. Well, but and there's no metric that captures hallucinations. Like, oh yeah, so this output is just a mere hallucination. Well, but instead you can develop some proxy metrics that can capture these things. And we know that empirically we know that if a model is hallucinating, so it's probably producing a longer output than the original. Well, it can also insert new named entities and things like that. So these small things can be broken down into small pieces and can be captured individually. Manual evaluation. Yeah, well, onboarding to annotation now takes time. As I mentioned on one of the previous slides, well, instead of just saying, oh, if you encounter this, label it as bad. If you encounter that, it's good. So refrain from this approach, create guidelines that will describe and define the concept. and that will enable you to do the knowledge transfer. Will contextualize your task. Well, instead of just providing annotators with these two pairs of sentences, you can say, okay, so you're looking at this type of writing. So the formality is formal, the style is creative, whatever. So the recipient is, I don't know, your boss, or you have to provide as many nuances as possible. And it's also a good idea to, well, ask your annotators to just to suggest wearing a user's hat. Like instead of being just voicing just your expert judgment, you can imagine you get this output. So, like, what is it that you like? How would you respond as a user to this output? And yeah, of course, you have to budget for more annotation time because these concepts are big and they require a lot of time. User-based metrics. I'd say you have to be descriptive on the one hand and prescriptive on the other hand. You have to rely on the user feedback. Well, if they like it, they like it. So they may not like conventionally correct things. But you need to trust your users on the one hand, right? And actually, if you need to collect more feedback from them, you can even add a feedback button or whatever to a UI and collect feedback on targeted feedback on what you are interested in particular, right? Well, but at the same time, it's a good idea to be prescriptive. Continue looking into the output and just try to improve the accuracy regardless. So engage linguists, engage annotators, and we'll try to identify the problems that can be improved regardless. Okay, let's go back to this pair of sentences, and now let's try to we'll think about an evaluation framework and reflect on what things could work in evaluating just to evaluate this kind of output. Automated metrics. Like I said, there's no single metric that would measure the quality of the improvement. So, this model has a great output. So there are no easy answers. Well, but instead, so there are some things that you can still measure, and I have just some examples. So it's a recommendation. I'm suggesting this approach. So be creative and experiment. Let's say you can, you might be interested in the recall of your model. How frequently it corrects things. Okay, large language models will correct a lot. But still, you can measure it. You can have a look at the length of the rewrite. You can have a look at so you can analyze the spans of your edits, and things like that. So you can so knowing more, you have to learn more about users, about their needs and preferences. And if you, for example, know that users do not like lengthy things, lengthy suggestions, so you can tweak the output. So that's already some control over what your large language model is producing. Well, you can also try some prompt-based evaluations. That's a whole topic. So, prompt-based evaluations can be also biased. So I'm not trying to say that, so that's a key role and that will do the job. But you can experiment with that. And manual evaluation. So break things down into small pieces. Provide your annotators with a data sample and ask them to have a look at the output and so analyze its correctness, so grammaticality. So ask them to identify optional rewrites. If, let's say, you know that your users do not want to get optional rewrites, right? So maybe that's something that's undesired. You can also, let's say, if you have several modules, several release candidates, so you can set up a preference test and ask human raters to select the best output, and that can also that's already some navigation. And so the last thing, user-based metrics. So create a dashboard So look at how your users interact with the feature. So what things they accept, what things they ignore, but still do not forget to engage experts, and will always compare it with the expert judgment. And yeah, I think that's pretty much it for today. I hope, so these tips will help you.
Yes, Olena, thank you so much for an incredibly interesting presentation and how important it is to think about evaluation. We all use LLMs probably every day, but how often do we think about evaluation? So I'm going to open up the floor for a few, we have time for a few questions. First, I'm going to ask a question I have. So considering the rapid pace of the advancements within generative AI, how do you foresee the role of the analytical linguist evolving over the next couple of years in shaping the development and evaluation in AI technologies?
I'm very hopeful. I need this job.
Yeah. Good.
No,
Yeah.
actually, so there are the advancements are great, of course, and so at times you might think, oh, okay, so the LLMs generative AI is doing a great job, and so humans will be superseded soon, right? Well, but in fact, so when you will take a closer look at the output, so this wow effect fades away, you understand that there's a lot of so that's a huge piece of work for humans. And in case of in a situation when you work with language data, linguists have to work with these questions. Right. I hope.
Yes. Perfect. Okay, let's see if there's any questions. Let's actually take the question right here in the front.
Hello, I'm Sarah from Cognic. Thank you so much for an interesting talk. I was thinking, because in kind of machine learning and data science, we often traditionally want to separate our input and output quite clearly. But it seems now that we have so much like AI generated text that it'll be kind of hard to keep it out of our data sets and input. And I was wondering if you, as a person who works a lot with large language models and language tasks, like, how do you think about that challenge? Is it a problem or not a problem? And how can it be tackled if it's a problem?
Thank you. That's a great question. So, I think I can only share some empirical things, so things that I worked with. So we still will keep data separate, we still separate data, right? So we have training data, we still collect data for fine tuning. So despite prompt engineering and things like that, right? So training data, evaluation data, so that's separate. Of course, large language model will see a lot of data. Just see a lot of data. Well, empirically speaking, I have not encountered these implications yet. So I may encounter them later. But so that's a great question to think about moving forward here. Thank you.
Perfect. We can take the question here on the side.
Hi, thank you so much for the presentation. Just a short question from my side is, have you tried doing the manual and the user-based tests with LLMs, like running these things multiple times, the same question multiple times, and using the LLMs as a verifier, as an example?
Oh, you're saying like whether we try to compare like human annotate output and a model annotated output, right? Like
exactly, and having the models do
yes.
it like 1,000 times.
So we have tried, but large language models are biased towards large language models.
All right, thank you.
Great, and I believe that is all the questions we have time for, actually. Olena, it has been incredibly interesting and awesome to have you here. Thank you so much for your presentation, and I'm also going to give you some flowers here.